Hello, this is continuation of what we have done already in the classroom. Now I am going to take Poisson equation. The general form of Poisson equation, you know very well. Del square u equal to a function of x comma y. So that is, this is in Cartesian form. You know how to represent dou square u by dou x square plus dou square u by dou y square equal to function of x comma y. You know very well what is a finite difference equivalent for second partial derivative with respect to x, divided by h square, where h is the step size along x direction. Similarly, so you know the partial derivatives, second order partial derivative in finite difference form, where h is the step size along x direction and k is the step size along y direction. Okay, now I'm going to assume for all numerical calculation square mesh. Assume that h and k are equal. That is, I'm taking a square mesh for hand calculation since we are doing using calculator. So therefore, I can write ui plus 1j plus ui minus 1j plus uij plus 1 plus uij minus 1 minus 4uij equal to h square f of x comma y. For any point, say for example x and y, how to represent in finite difference form? X along x direction, I followed by h. For x direction, you know the step size is h and I indicates the numerical value for each and every step. By setting I equal to 0, 1, 2, 3, then you know you will get x equal to 0, comma h, comma 2h, etc. Similarly, for y along j, that is step size k. So this is what the finite difference equivalent for coordinates x comma y. So this is something new. This we have done already, but this is something new. The replacement I have enclosed in the rectangular box. Now I'll rewrite ui plus 1j 4 times ui plus 1 uij ui plus 1j plus ui minus 1j plus uij plus 1 plus uij minus 1 minus h square f of ih jh, since h and k are equal. Therefore, we will write the finite difference equivalent for Poisson model is ui plus 1j, ui minus 1j plus uij plus 1 plus uij minus 1 minus h square f of ih jh. So this is what the finite difference formula for Poisson equation. Now I am going to fix the coordinates by giving some titles A, B, C, D. I think U1 is nothing but coordinate A, which is nothing but 1, 2. B is a coordinate 2, 2. C is a coordinate U3, 1, 1. And D is a coordinate 2, 1. Now, you know very well, now we start with any random point. For example, I start with at point A. At a point A, 1, 2. That means I equal to 1, j equal to 2. Now I am going to apply this finite difference scheme. As you know very well, the first 4 points is nothing but is a cross averaging of points. So I am taking cross averaging as taking a point A, that is all your immediate 4 neighborhoods okay, north, east, west, south. So I'm going to travel 4 directions. I'm taking average value and I'm going to include this point also. Now I'm going to write, so at A, u1 equal to 1/4 of, okay, this boundary point top 1 plus u2 b, and then u3, and then 0. Now I am taking at a point A, I am taking 4 points. This divided by 4 is a common, the last point 0 plus 10 times I square. You know I, the coordinate 1 square is 1, 2 square 4 plus 10. Therefore, so on simplifying entire equation, u2 plus u3 plus 150. So let it be, this one is equation 1. Now similarly I am going to take the point B. The same way, the coordinate system 2, 2, I equal to 1, I equal to 2, sorry, j equal to 2. So we'll repeat the same procedure at point B. So u2 is 1/4 of, okay, taking cross average 0 plus 0, u1 and u1. So this is the way we have to take. So 0 plus 0 plus u1 plus u1 plus 10 times I square 4 plus 4 plus 10. Okay. So therefore we'll rewrite this equation 1/4 of 2u1 plus 180. This is my second equation. Okay. Now you take point C. At C, the coordinate system 1, 1, I equal to 1, j equal to 1. Therefore, u1 is 1/4 of, same way I am going to take cross average at a point C, or u3, take cross average. So 0 plus 0 plus u1 plus u1. Of course, this is duplicated by coordinate symmetry. 10 times I square 1, j square 1 plus 1. Okay. On simplification, u1 1/4 of 2u1 plus 120. This is equation 3. So now we are going to solve these 3 equations either by Gauss-Seidel method or algebraic method. If we go by Gauss-Seidel method, it's an iterative method, it's a time-consuming method. If you go by simple method, algebraic method, substitute 2 and 3 in equation 1. Why I am substituting equation 2 and 3 in 1? The reason is u2 in terms of u1, u1 in terms of u1. Of course, in this case is duplicated. It's very clear, both u1 and u2 right hand side is in terms of u1. I'm sorry, this point is u3. I'm taking by mistake. I'm sorry, extremely sorry. So this is u3, not u1. So u3 is also in terms of u1, u2 also in terms of u1. Please check, our diagram shows u3, not u1. please correct the mistake. Now I'm going to substitute 2 and 3 in equation 1. So u1 is 1/4 of u2. So how I am going to simplify straight away? 2u1 by 4, of course u1 by 2, plus 180 by 4, 45. Okay, this is after substitution u2. Next, u3 is also in terms of u1 by dividing separately u1 by 2. Of course, this is 30. Yeah. Now I am going to simplify further. 1/4 of u1 by 2, u1 by 2 is u1, and this is 75. So u1, just take LCM, 1 minus 1 by 4 equal to 75 by 4. So u1 on simplification, of course, yeah, So u1 is 75 divided by 3. So you know very well, we're using a simple calculation. 75 divided by 3. 75 divided by 3. Plus one more value, I think we have excluded. So 150 plus 75, it comes around 225. I'll overwrite 225, not to 75. 225. Yeah. I'll repeat from this step. I'm substituting in equation 1, u2, yes, I've substituted. After dividing separately, u3, yes, I've substituted, plus 150. So now only I've added 150. By adding all those 70 plus 150, 225, I think now 225 divided by 3, 75. So this is what my u1. Now take equation 2. If we take equation 2, so u2 is 1/4 of 2 times of u1. Yeah, this is what u2. By simple calculation, this is 150 plus 180 divided by 4. If using calculator, you can calculate, yes, 82.5, corrected to whatever the displayed value is, 82.5. Similarly, take equation 3. If we take equation 3 and substitute to solve problem using Poisson equation model. Let us take this problem, del square u equal to minus 10 times x square plus y square plus 10 over square mesh with sides x equal to 0, y equal to 0, x equal to 3 and y equal to 3 with u equal to 0 on the boundary and mesh length is unity. That is, here the 4 sides are given to you. The mesh is entirely a square type, is very clearly given, and entire temperature on all 4 sides is set to 0. That is what u equal to 0. And of course mesh length is unity. That is length and breadth are 1. H and k are 1. Let us first start with the finite difference formula for this model straight away. So del square u by dou square u by dou x square, dou square u by dou y square equal to minus 10 times x square plus y square plus 10. Okay, you know the procedure as what we have done in the bookwork. X is IH, y equal to JK. So I am going to replace finite difference equivalent. So ui plus 1j plus ui minus 1j minus 2uij by h square plus uij plus 1 plus uij minus 1 minus 2uij divided by k square equal to minus 10 square, 10 times, I square h square plus j square k square plus 10. Now we are going to assume h and k is 1. Why? Because that is given as unity. So I am going to take h and k is 1. Therefore, the reduced finite difference form the entire finite difference form reduces to ui plus 1j plus ui minus 1j plus uij plus 1 plus uij minus 1 plus 10 times I square plus j square plus 10. Okay, so this is what the entire finite difference scheme. So this is what the finite difference scheme derived for this particular problem based on our theoretical analysis what we have done in previous studies. Now how we are going to take the domain. This is a square domain. Okay, coordinate system x and y. I'm going to divide the region this way. Of course, you know very well this is y equal to 0, and this side, that is x-axis, y equal to 0, y-axis x equal to 0. Now this line x equal to 1, x equal to 2, x equal to 3. Lines parallel to y-axis. Similarly, lines parallel to x-axis, y equal to 0, y equal to 1, y equal to 2, y equal to 3. Yes, we know now all these four sides with the prescribed boundary conditions, that is the temperature on all four sides is given in the problem u equal to 0. Now, of course, this one we take the first coordinates. Let us take this coordinate. You know very well the coordinate is 1, 1. And this coordinate 2, 2. And of course, you know very well this coordinate 2, 1. And this one 1, 2. So it's very clear we are going to use the concept of symmetry. Why? Because all four boundaries are equal temperature, that to 0. So we can go by symmetry. Here the four internal nodal points we have to find out. So for example, this is a u1 and this is u2 and this is u3, but this one is u4. Of course, instead of u4 we are going to use the concept of symmetry. You should be very careful when you fix the coordinate symmetry. I mean, I'll explain. Now you see the coordinate here u1 1, 2, whereas this coordinate 2, 1. So if we swap I and j, that is what I mean symmetry in diagonals, that is coordinate symmetry. So instead of taking u4, you have to take u1. You just fold this particular square domain into triangular domain by just like paper folding. Now you can observe this line is a line of symmetry. So this u1 coincides with this particular point. So that's why I'm duplicating this as u1 instead of u4. Normally we label u1, u2, u3, u4, but I am taking this one as u1. Why? Because this preserves coordinate symmetry. So in Poisson model, so this is very important, whereas in Laplace model we just take symmetry based on the boundary condition. Here the boundary conditions are all are 0, and moreover I am taking coordinate symmetry. That's very important to reduce the number of points to 1, that is to 3. So here totally 4 internal nodal points. Our aim is to find out only 3. With reference to this diagram, now I am going to write the finite difference equation. Equation 3. So we know how to arrive u2. Now take equation 3. Why? Because I want to find out u3. I know u1 and u2. Let us find out u3 also. So from equation 3, u3 is 1/4 of 2u1. u1 is 75 plus 120. So you'll get this value as roughly 67.5. Now you check with the calculator, and therefore the final answer u1 is 75, u2 is 82.5, and u3 is 67.5. Thus the problem is simple and straightforward model, Poisson equation. So what to do? So try to understand the bookwork behind this Poisson model. How to start with this one is a Cartesian form. Right hand side given to you in the problem. You know how to transfer this into finite difference form, and is clearly given the mesh length is unity. Just substitute h and k, simplify clearly, and write finite difference equation for any model. And the domain is clearly defined. The sides x equal to 0, y equal to 0, x equal to 3, y equal to 3. The domain is square. I am dividing the region. So we'll get 4 internal points we want to find out. We are using the coordinate symmetry. That's very important, this model. After that, coordinate symmetry, label all the coordinates A, B, C, D. Then you write down the finite difference equations. That is, you'll get a system of equations. These are all diagonal dominant, ready for iteration. You can go by Gauss-Seidel or by simple shortcut method by direct substitution. Why? Because u2 and u3 in terms of u1 and the first equation u1, so you will get purely in terms of single unknown u1. Once you know this single unknown, you can find out the remaining unknowns u2 and u3. It's a standard 16-mark problem. You can easily crack this problem in any exam, either on our university or any system, in computational method, in specific Poisson model. Thank you.